All right, so what we've got for this problem, they give us -6 times the quantity y plus 1, and then we're adding 8y, and then we're told that's equal to 2 times the quantity y minus 3. So this is a job for the distributive property. So whenever you see the parentheses like this, and you've got something added or subtracted inside it, you are going to multiply whatever's outside and multiply it by everybody inside. So you say -6 times y, also known as just -6y. There's a plus right here, so we're going to bring down the plus, and this is -6 times 1. -6 times 1. Bring down the 8y, that's still there. Here we're going to distribute yet again, once more with feeling. 2 times y is 2y, 2, and then anytime you see like a -3, that's another way of saying like a -3. But basically this is a +2. The minus goes along for the ride as a negative sign, and so that's going to be -3. So this is 2 times -3. If a student were to make a mistake on this problem, I would bet you good money that's exactly where it's going to happen. Because the thing to remember is the plus or minus sign goes along, especially a minus sign goes along for the ride. If it's a minus, that's the same as saying -3. So you multiply out and clean all this stuff up. You got -6y, whoop, got out you. -6y, this is -6 times 1, which is -6. You could say plus -6, which is another way of saying -6. Bring down your 8y, here's 2y, 2 times a -3 is a -6, or a -6. You could say plus -6, that's the equivalent to saying -6. Now we're going to combine some like terms. So here's -6y, here's plus 8y. Well, guess what? -6 plus 8 is a +2. So now you have 2y. It doesn't become y squared or anything. There's only one y to go around. So it's just 2y. Bring down your -6. This is also 2y minus 6. Something kind of funny happened, because if you're doing a normal equation, you kind of go on your merry way and you like bring the y's together on the same side. You'd like add or subtract them, and you'd find a value for y. But here something kind of funky happened. This is one of two possible funky things that can happen when you're solving an equation. These are exactly the same. So it turns out that it doesn't matter what value of y you pick. You could pick 8 or 10 or 58 billion. Any value of y you put into this equation is always going to be equal. So because those are exactly the same, that means you say the solution is all real numbers. Y can be anything, anything at all, because this is basically like saying, you know, the dog is a dog, and like this is the same as that. It's really mathematically, it's not a very interesting statement. But what it means is any value you pick for the variable, those will be the same. Now here's something else that could happen. I've changed the above example ever so slightly, and this is the other kind of funky thing that can happen if you're trying to solve an equation. So you got -6, you're distributing it with y plus 2, so like we did before, you got -6y plus -6 times 2. You distribute this, which is exactly the same, that's still 2y minus 6. You distribute that, you get -6y minus 12, there's a plus 8y right there, and there you go. And combine your like terms again, -6 plus 8 is also 2y. And if you were to solve this equation, essentially what you need to do is you need to do -2y on that side of the equation, and you need to do -2y on that side of the equation. This and that are going to cancel out, and this and that are going to cancel out. And so since both sides drop out completely and they cancel out, what you're left with is a -12 over here and a -6 over here. So you basically ended up with a statement, -12 is equivalent to -6. Last time I checked, that is not a true statement. Those are two completely different numbers. So if you get something that is complete utter nonsense, where your variables drop out entirely, that means the answer is no solution. You can't pick a value for y anymore, because guess what? Y is up and gone. So there's no solution to that problem.